Okay, good afternoon, everybody. My name is Rudy Shankar. I'm the director of the Energy Systems Engineering program here at Lehigh University. And welcome to our Energy Systems Engineering seminar, fall series. And we will be presenting the 6th seminar in the series. And I'm so pleased to introduce Virginia ECHINOPE. She's in the Ministry of Industry, Energy, and Mining at Uruguay. And the title of the presentation is Renewable Energy in Uruguay, the Challenges and Opportunities. And I think this is going to be a fascinating talk because it not only talks about how Uruguay its portfolio of generation is so clean, almost 100%, but also the changes they made along the way. And this has been very long, drawn out. It's almost like a lesson other countries need to follow to be able to not only meet the goals under the Paris Agreement, but also be able to live by the goals under the Paris Agreement, which is a human behavior part. So the abstract of our talk, Uruguay is among the countries in the world with the highest share of renewable energies in the electricity matrix. This position was achieved through an aggressive development of wind and solar, driven not only by environmental reasons, but also to strengthen its electricity sector. In this seminar, Virginia will talk about the development of renewables, the challenges that they pose to the operation of the system, but also will explore the opportunities that came with these developments. Nowadays, there's no doubt that renewables are the option to continue with the development of the country's energy system. So the discussion will be about the next step and the challenges as they go forward. Now, Virginia has got a background in electrical engineering from the University of the Republic and has been head of the electric energy area from the National Directorate of Energy or the Ministry of Industry, Energy, and Mining of Uruguay since 2007. Her work experience includes energy planning, development of alternative resources for electric energy generation, evaluation of regulatory aspects of the electricity market, and electromobility development. She has actively participated in the design of policies for wind and solar energy integration. Her experience in energy planning includes a study for long-term expansion of the electricity generation system, as well as a selection of tools for the development of renewable energy systems in medium voltage and low voltage networks. She's contributed to the determination of tariffs for the electricity sector, to the development of off-grid projects for rural electrification, and to the analysis and reformulation of Uruguay's regulatory frame for the electric sector. Since 2003, she's been working as a professor of the Faculty of Engineering with research and teaching experience in power electronics, power quality, and energy planning. So welcome, Virginia, and look forward to your presentation. And just before you start, I just wanted to let you know that at the end of our talk, we'll be entertaining questions from the audience. I'm going to ask the students first to come up with the questions and then ask the general audience to follow. So anyway, Virginia, the floor is yours.
Okay, good afternoon, everybody. Well, first of all, thank you very much for inviting me here to this seminar. I'm very honored to be here and to be able to talk to you a little bit about Uruguay and how we have developed renewables here, and how are the challenges that we face in the future and that we're facing right now. So I hope you find my presentation interesting, and of course I am available for any questions you may have at the end. So I'm going to start to share my screen. Can you see it?
Yes.
Okay. Well, as Rudy said, the presentation is about renewable energy in Uruguay, the challenges and opportunities that we have. But first of all, I wanted to talk to you a little bit more in general about Uruguay, because we're a very small country, and many of you perhaps haven't heard about us before. So I will start with a country overview. And here we are. This is Uruguay, the little pink here. This is South America. We are between two giants like Argentina and Brazil. As I said, we're a very small country. Our land area is less than 2,000 kilometers. Our population is 3.5 million of inhabitants. Our annual growth rate of population is very small, it's 0.3%. We have a very low density of population in the country. Most of the population is here at the south of the country, in Montevideo, that is the capital city, and almost in the south area of the country. We have a very high life expectancy in our country, and a low infant mortality rate. And the GDP per capita is around $1,500 per year. But we are very well ranked in Latin America. Although being small, we are number one in many aspects, in the democracy index, and the low corruption perception index, in the civil liberties index, and the rule of law index, and the social mobility index, and the e-government development index also. And we are the number 6 in the world in the global freedom index qualification. We have had a steady and stable growth in the last, an uninterrupted steady growth in the last 16 years of 4.1% an average in those 16 last years, well above the average of Latin America, and also well above our giant neighbors like Brazil and Argentina. And we have proved to have a strong resilience to external shocks. This growth has been made with equity. We have grown in the income per capita as long as we have grown in the income distribution. And we also perform here above the average of Latin America in these two indicators. And we are among the highest performance in the ESG factors, as for environment, social, and governance, if we compare with other countries, also in Latin America, but in other parts of the world. Just to put you in perspective, as I said, we have a very low density of population, and because our main activity here in Uruguay is agribusiness and food. We always say that we have more cows than people in Uruguay, because but it is true. It's not just something that we say, it is true. And 49% of our exports come from agribusiness. We have, in the last years, we have also come very strong in exporting global services and trading, also IT, business, trading, and financial services. And of course, tourism is another big sector in Uruguay. So that was just to give you a glimpse, and I will go back in some of the figures that were in the past slides, because many of the other figures that I'm going to talk about and how we have developed renewables is relevant to keep in mind that we are a small country, and you have to put in perspective what this development has in our scale. So now let's go to the energy sector more specifically, and let's talk about the energy framework and the historical background that lead us and take us to where we are today. This has a very strong influence in our development, because we have no oil, we have no coal, we have no natural gas. Okay, that's three important factors for us. So every energy that comes from oil, coal, or natural gas has to be imported in Uruguay. We have had a long tradition on the development of renewables that started with big hydropower plants. In the early of the past century, we started developing hydropower plants. So nowadays, we have no space for new hydropower plants. I mean, new big projects. Of course, there is a potential for the development of a small hydropower plants, but not for big projects. Okay, the potential is almost exhausted. And in 2005, when all these things almost started, there was an absence of energy efficiency culture in the country. And that's one of the things that has been developed along with the development of renewables in the country. So if you take a look at the energy matrix in 2005, you will find that 63% of the energy was imported and only 37% was locally generated. Of course, most of the 63% imported came from oil imports, almost all of it. And the locally generated energy came from hydroelectricity and from biomass. So in 2008, came the development of a new energy policy that was approved by a council of ministers. Then in 2008, it became a state policy that was ratified by a special committee, including all political parties in the Congress. And this is a key element for the development of renewables in Uruguay, but because all the political parties agreed that this was the path that the country had to take. This policy in 2020 became a state policy, had a state policy adaptation and ratification, integrating a multidimensional and integrated vision, including technological, economic, environmental, ethical, and social issues. But going back to that state policy, it had 4 strategic guidelines, an institutional guideline, the energy supply, the energy demand, and the social aspect. In the institutional, they recognized the leading role of the state in the development of the energy sector. Of course, it included a regulated participation of private actors, but it gave big importance to the role of the state. In the energy supply axis, it claimed from the diversification of the energy mix. And why was that? Well, it was just to reduce the proportion of oil imports in the country and the development of domestic resources, promoting non-traditional renewable energy. At that time, it was wind and solar and biomass, and also very important to build local capacity and to maintain a low carbon footprint. In the axis of the energy demand, we had a very strong promotion of energy efficiency in all activities, in all activity sectors. And also it had a social axis that claimed for an adequate energy access to all citizens as a human right. Going now, I'm going to narrow the view to the electric sector in Uruguay, and start from there, from that point, and see how it has developed through those years. So I'm going back here. Uruguay, remember, we have no oil, no natural gas, and no coal. And we have almost no space for new large hydropower plants. I put it here some figures of the electric sector just to you to put into perspective the next figures that I'm going to talk in the next slides. The annual electric energy consumption in Uruguay is around 11,000 gigawatts per year. We have a high electrification rate. 98% of the population here in Uruguay has electricity. The mean annual power demand is 1,250 megawatts. And the peak power demand, the last peak power demand that we had, was around 2,000 megawatts. So it's a small electric system. So keep in mind these figures, because that's the relevance that the development of renewables will have according to those figures. It's very important to me to tell you a little bit about the regulatory framework of the electric sector, because I think that it helped us a lot in the development of non-conventional renewables. In Uruguay, the electricity generation and the energy commercialization are free activities and are open to public and private agents. The transmission and the distribution, of course, are natural monopolies and are under the jurisdictions of UTE. UTE is a state-owned public utility that in 2005 had, of course, the transmission and the distribution of all the country, okay? But it also has the property of all the thermal power plants, all the hydropower plants, except from a binational project that we have with Argentina, but it is also state-owned. And of course, all the generation was from UTE. It's a large company in Uruguay, and it has all the distribution all over the country. In the electricity, there's a wholesale electricity market that has a contract market and a spot market. The spot price in Uruguay is determined from variable cost of generating unit. We don't have offers here, okay? Once you have a power plant, no matter what is the resource of the power plant, and it's connected to the system, it is centrally operated by the National Dispatch Center, and you don't declare price, you declare variable cost, okay? We don't perform offers like in other markets, and that is something that is different here in Uruguay from what I have seen in other countries. And I found interesting to let you know something about wind and solar specifically, that are, as I said, they are dispatchable. They have zero variable cost, and the generation is determined by the resource availability. Okay, once the plant is available, if there's wind, if there's sun, it has to generate, and they are subjected to curtailment. Okay. So, I mean, this is, I wanted to tell you this clearly because I think that the presence of the state-owned utility there, in a strong presence there, was the key for the private investors to be confident that they will be able to sell all their energy and be paid for that. So what are the general characteristics? Well, this is the transmission system in Uruguay. Just to give you a glimpse, there's a high voltage transmission system of 500 kilovolts that is under development. These violet lines and these green lights are actual projects that are coming in line, that have come in line in short and will come in line in the next few years. And the lines in red are the transmission system in 150 kilovolts that are all around the country. And this is the distribution system. As I said before, we have a very high electrification rate in the country. This is the medium voltage distribution network. that is in 30 kilovolts, 15 and 16 and 22 kilovolts, those networks. So when the development of renewables started, we have in 2007 0 megawatts of wind power, and we reach 1,500 megawatts of wind power installed in 2019. This is the pace for that development. For the development of wind power, of course, in the beginning, we had to learn a lot. We have to measure. We have to install wind meters. So we have to, because the private investors wanted to know what was the resource, and most of them weren't willing to take the time to have the measurements. So the state had a strong presence in giving information for them to prepare their project. Because how was that this was developed? Okay, the government asked the public utility to celebrate 20-year PPAs with the wind power plants owners. So the electric company will have to celebrate contracts for 20 years. And of course, there was a tender, and they have a competition, and the project that were assigned a contract were the ones that have the lower prices. But this was the key element. They were sure that they're going to get their energy bought. This was how wind energy was developed in Uruguay. And a similar path came from solar energy. Just as solar energy, it was that we had a development of solar thermal energy that started earlier, but in the electric sector, the solar power that came from photovoltaics started earlier. I'm sorry, started later. Why? Well, because it was more expensive. Because in Uruguay, we have a commitment with the environment, and we have our goals to 2050. But when we started with these projects, I must be honest, this was because of dependency and cost. Okay, I'm going to show you how was the impact that we have before the development of renewables in the electric sector, and that was one of the main drivers for the beginning of this transformation. We also developed biomass. Nowadays, we have 425 megawatts installed in Uruguay. They generate from burning forestry residues, rice husk, bagasse, and black liquor. The development of biomass generation was developed with a high percentage of national components, and they are all over all over the country. They're distributed all over the country. The installed power, you can see here the pace. It started in 2009, and it grew up with big projects and in the following years. And they are also distributed all along the country. As a complement for big projects of renewables, we developed a regulation for microgeneration, that it was the installation of renewable generation in homes and in small industries. I mean, those who were connected to the low voltage network will have the possibility to install generation, auto generation for their own consumption, and the public utility will buy the energy injected into the grid at the same price as they sell. It was a net metering contract. But it was just for renewable generation. We were among the first countries in South America to bring this opportunity, and this is how it has developed during the years. Now we are under revision of this method, because it has had a big development for us, and we have to adjust some things in the tariffs there in order to not to harm the finances of the utility. And also we promote the self-consumption. We create a new regulatory framework for prosumers, or those who generate and consume electricity. They can install electricity in their installation, and they are not allowed to inject electricity to the grid. It's only for self-consumption. This is just for tariff reasons. If you want, we can talk a little bit more about that. But also because tariffs have a big percentage of fixed cost in the energy component of the tariff. So if you have someone that installs generation just to consume, well, the utility will not be available to recover all its fixed costs. And this is how is the electric matrix today in Uruguay. We still have fossil fuel power plants installed, gas turbines of 500 megawatts, a combined cycle of 500 megawatts, and some motors of 80 megawatts. They are all installed here. The fossil fuels is here in the capital of the country, and the renewables are all over the country. We have hydropower plants. That's where the ones that I was talking before, 1,500 megawatts that came from 3 hydropower plants that are installed here in the middle of the country. We have a river that cuts the country into halves. It goes from here to here, and 3 of the hydropower plants are here. The second one, I mean, the first one here is the energy, the biggest energy storage that we have in the system. It has the possibility of 5 months of energy storage, or the possibility to generate at full capacity for 4 months if the reservoir is full. And we have here the biggest, in the north part of the country, we have here the biggest hydropower plants. That is a binational project with Argentina. We share half and half. It's 945 megawatts for Uruguay and 945 megawatts for Argentina. I mean 18,090 megawatts in total. This gives us most of the power, not the energy, because the storage is not too big, but it's one of our biggest reserves for power, instant power in the system. And we have an electric system, but it's very, very well interconnected with our neighbors. The arrows here are the points where we are interconnected. We are interconnected with Brazil. We have 50 hertz frequency in the system, and you may know Brazil is 60 hertz. So we have here back-to-back converters, and And we have an old frequency converter here of 71 megawatts. And we have a bigger one that has been in line since 2018 of 500 megawatts with Brazil. So our total interconnection capacity with Brazil is 571 megawatts. This is in red because it's connected to the 500 kilovolts network, and this is in blue because it is connected to the 150 kilovolt network. And with Argentina, we are connected through 4 points, two lines here and 2 lines here. That is in 2 lines in Salto and 2 lines in Paysandú. The ones in Salto are related to the Salto Grande hydroelectric power plant, and the capacity of the interconnection with Argentina is 2,000 megawatts. So keep in mind, I told you before that our peak demand was 2,200 megawatts. So we have more interconnection capacity than our peak demand. But don't be so enthusiastic, because our systems are interconnected, but they are not integrated. This is one of the challenges that we have to face into the future. We are not Europe. The systems here, it's difficult, and it's difficult for a small country like Uruguay to I don't want to use the word fight, to talk sometimes with huge countries like Brazil and Argentina. The electric system in Brazil is 10 times our system, and the electric system of Argentina is 5 times our system. So what for us are huge amounts of energy, for them it's sometimes not to be, and that's inequality and in size is sometimes difficult for us, because of course you may know that one of the key elements for the development of renewables is the integration between systems, and to take advantage of different regimes of demand to be able to exploit all the potential of renewables. So I talk about what was the energy policy, what did we do with that energy policy, what did we develop with that energy policy in the electricity electric sector, but what were the impacts? Okay, first impact. We had a power generation system like this, okay? As I said before, 3 hydropower plants in the middle of the country, 1 hydropower plant in the north part of the country, and thermal units in the capital, where the main consumption is located. Well, this is the power system right now, because wind and solar are distributed all over the country, and they are connected to the medium-low voltage network and to the high voltage network. So this was the first challenge here, that from every point of view, from the operation point of view, we had a static system here. Okay, we talked with the hydropower plant on the phone. Okay, the frequency control was held with Argentina through Salto Grande, or sometimes through a machine, a generator in Buenos Aires, that is the capital city of Argentina. But when we started to develop wind and solar, Argentinian says, okay, I don't want to cope with wind and solar variability. You will have to cope with that. So in our link, because I didn't say it, but we are 50 hertz, both countries. So the link here is an AC link. So it's like a unique system. So, but they say, okay, but I don't want to cope with your wind and your solar variability. So you will have to do something here. So we don't want to see in our lines that link us with Uruguay those variations. So one of the things that came right away. It was the development of an AGC control system, to be able to give some flexibility to the operation of our power plants, our hydropower plants and our thermal power plants, in order for them to cope with wind and solar variability. And also, one of the other challenges that we have to face was the transmission system. We have a transmission system that mostly the power, the energy flow was from north to south. But when we started with the development of wind and solar, the energy flow was all around the country. So we have to change the way we plan the expansion and the operation of the transmission system in the country. This is how it has impact in energy. I started here in 2002, just for you to see what was our problem. The problem, the blue is hydro energy. The next kind of orange here is thermal power plants, fossil fuel power plants. The gray line, the green area here is thermal, but biomass. And then here with violet and pink are imported energy from Argentina and from Brazil. And then at the end, it starts the green, that is wind, and the yellow, that it is solar. So you may see here that from one year to another, we can go from having, 2002, it's a good example. Almost 95% of the electric energy was generated through hydropower plants. And the remaining, we purchased from Argentina. But 2 years later, 2004, it was a bad year in terms of rainfalls, because our hydroelectricity does not depend like in other countries. Uruguay is a very plain country. We don't have mountains. Our highest mountain, if I may say so, is 500 meters of height. So it's quite a plain country. Okay, so we depend on rainfall. We don't have a snow and then the spring and the big. We don't have that. So if it doesn't rain in 1 year, we have problem with hydroelectricity. And when we had problem with hydroelectricity in the past, we had to rely on thermal power plants, and this means imported oil. Or if Argentina and Brazil had a surplus of energy, well, we were able to import that energy from that country. Okay, but it was a big weakness of our electricity system. And you can see here that when we started to develop wind and solar, we dramatically decreased the participation of oil in our electricity matrix. Even in 2020 was among the worst years for hydroelectricity in our country. And even though it was one of the, I mean, we have records of the last 100 years of hydroelectricity, I know not hydroelectricity, but rainfalls. And 2020 was one of among the 5 worst years in our history on the availability of hydroelectricity. And despite that, the consumption of oil was very, very low, and most of the energy were provided because there was a little bit imported energy from Argentina and a very slight amount from Brazil, but most of it came from biomass, a very large amount from wind, and of course a part from solar. And this is a cut of some of the years we've seen there. This is the demand. How was the supply of the demand in 2012? It was a year that 51% of the energy was generated by hydroelectricity. We have a very small amount of wind at that time. So 37% of the energy came from fossil power plants. And the cost of electricity generation that year was $1,500 million. The next year, 2013, still small amount of wind installed, but a good year for rainfall. So 77% of the electric energy came from hydropower plants, and only 70% came from fossil fuel power plants. And then the total cost was $800 million, almost half of the year before. And let's take a look at 2016. It was a year between, in terms of hydroelectricity, between 2012 and 2013. So 63% of the electric energy was generated through hydropower plants. But now 27% of the energy came from wind. When the total cost that year for the electricity generation was $400 million. So we have less, a little bit more hydroelectricity than we have in 2012, but less than what we have in 2013. And yet the cost of supply, the cost of the demand supply was small. So as I said before, yes, we're talking now about environment, and we have a commitment as a country to come to be carbon free in our energy system. But at the beginning, this is one of the main drivers for the development of wind and later on of solar in Uruguay. The high uncertainty that we will have from one year to another in the cost of electricity, that it will reflect in the tariffs of the final users. And this is another consequence of renewables. This is a week. I mean, it's not a week. It's the last 48 hours. I mean, this is September of 2020. So this is how you see the system hour by hour. Okay, the line here in orange is the demand. The base is biomass, because they are always related with industrial process, and they are running in the base. They are not dispatchable. They are constant, almost constant. What we see here is solar, the yellow, and the green is wind, and the rest at this time is the blue is hydro, and a little bit here of thermal power plants in this peak here and in this peak here. So you can see the variability that wind has, and how you go from 1 hour to another, and we'll have to change. And here we have a good position, because hydropower plants are among the fastest generators to come in line and to follow a demand curve. So they are the perfect companion for the development of wind and solar. I'm not saying that thermal power plants can't do the job, but hydropower plants are better in that subject. And here it's just to look something that we have to cope, and just to look more in detail. I mean, I'm sorry, but the last was a week, and this is the last 48 hours. And you can see here more specifically how the generation has huge variations in a few hours. Here's the biomass again in the base, the solar here, and the green is wind. And you can see the pink line here is the demand. And now here the demand goes down. So at this time, all the energy in Uruguay came from biomass and wind. And the rest at this time, I think that we exported it to Argentina. And we were having a great time here, almost wind, and then wind start to go down very quickly. And of course, and luckily, we have water. And so what the hydropower plants will take the main generation here and cover for the wind decrease. But as I said before, this is one of the things that had to change, and our national dispatch had to develop a lot of tools to cope with this variation. Not only the automatic generation control, but also they develop automatic line rating in order to see if the wind is blowing, if they can increase the rating of the transmissions lines, in not to curtail wind energy and solar if it is the case. This is how we have how I thought it was interesting to show you that the development of renewables came with more availability for exported energy. And at the beginning, and this, I think it was kind of the learning curve, we have a lot more curtailment that we have decreased in the last years. We still have, but it is not as significant. The worst year was 2017. This was the year when it came the highest, the last big wind power projects came in line. And of course, for the system, it was difficult to learn to operate with that uncertainty and to keep it to keep the operation for the system in a secure place. But of course, we have transformed from a regional energy importer to a regional energy exporter. After, before the development of renewables, Uruguay was a net importer of electric energy. And since the development of renewable, we have became a regional energy exporter. And I show you how it was the energy supply matrix in 2005. 63% of the energy was imported, 37% of the energy was locally generated. When in 2019, it was all the opposite. It came that 37% of the energy, I'm talking not about electric energy, I'm talking about all the energy in the country. 37% was imported energy and 63% was locally generated. After the introduction of renewable energy in the electric generation system. And this is something that is nice to see and nice to look, that even though our economy has grown more than 3 times in this whole period, we have the same old consumption, almost the same old consumption for the last 55 years. And the development of renewables has a very important role in that contribution. So what are the future and the present challenges that we face? Well, I talked about a little bit about the present challenges and some of that we have already coped with. But this is not finished. Okay, we still have to work, because I'll show you the figure here in the upper right of the screen. It is the electric generation matrix and the introduction of renewables. But if we look at the whole energy matrix, we still have a strong participation of oil there. And if you take an in-depth look of this 36%, you will see that 81% of that 37% is for transport. So the next thing that we have to deal with is with the the transportation, the transport in Uruguay. So what are the opportunities that we have in green? Okay, we have developed renewables. When we look into the future, we see that we still have to keep on relying on wind and solar, but we have to optimize the complementarity of the renewables with the demand and with other resources. We have to improve the management of energy demand and storage and find other means of storage, and not to be reliant on thermal power plants. We have to find a way to use renewables energy surplus. I'm going to show you that in the next slides in the industry. And we have to meet it to jump to the next level in the export of green hydrogen. I'm going to go fast because I'm running short of time with this, but we know that we have good solar and wind resource. The solar potential in just in 5% of our land is of 550 gigawatts, and 30 gigawatts of wind. Just the 5% of the Uruguay lands area has that potential. That's something that we still have. It still has to be developed. Of course, and we have the offshore wind. That is the next step. Is something about cost. It's something about learning new things for us to develop. We don't have experience, but we have to see that there is a potential there. We have 2,075 gigawatts potential for the development of wind in offshore. And of course, this is something that we're taking an in-depth looks for the development of green hydrogen exports. Electricity surplus. When we perform the long-term expansion of the generation system, if you have a big amount of renewables, you will have electricity surplus. There is no way, because even though you have to curtail that energy, it is still the best option in terms of cost. Of course, if you can sell it to Argentina, you can sell it for Brazil, you can find a flexible demand to use those electricity surplus, it's even better. But even though you have to curtail that energy, developing wind and solar is still the cheapest option for us in the future, and we will have surpluses. There's no way when you have such big amounts of renewable energy of I mean, if they are driven by the natural resource, there is no way that you don't have electricity surplus. So, at the first energy transition, that was what I talked before, this has been completed, and we have almost decarbonized the electricity matrix. So we're currently working in the second energy transition, that it is going to decarbonize the rest of the sectors, mainly transport, but also industry. Develop a green chemical industry and make the energy system in general more efficient. So this is the main drivers that we have. The electricity sector, of course, is key in this second energy transition, but it has its own challenges. We have to find instruments to flexibilize the demand of electric energy. We have to cope with the electricity supply for electromobility, mainly public transport, utilities, and domestic vehicles. We have to work in how to develop distributed generation and also storage. That is something that we're starting to see. We have to work in the development of service and products for a demanding market. I mean, green energy for industry is something that is being demanded. We have to work, I said before, we are connected to Brazil and to Argentina, but we don't work integrated. And that is something that we have to work to improve. And we have to see how we generate electricity for green hydrogen. That is a big challenge that we have, and I hope I can tell you why. Again, let's take a look at the picture that I showed you before, but from other perspective. The dispatch from the last 48 hours. I said, okay, we have here that in these hours here, the demand goes down, and at that time we were able to export that energy to Argentina. And here too, a little bit before the wind started to go down, we were able to export that energy to Argentina. But take a look at the bottom here. What is the time? This is between 0 and 6 a.m. in the morning. This is between 0 and 6 a.m. in the morning. So we have surplus in these hours. Well, that's an element to develop electromobility. This is the time where electric vehicles will charge in their homes. So we have to, it will be a rational thing to do to develop electromobility in Uruguay, because we will have green energy for that vehicles. So this is one of the things that we're working now. I'm going to go very fast here. I don't have much more time. We have been developed electromobility with specific measures because electric vehicles are still expensive for us. So there has been some instruments to have a cost reduction for the one that has to make the investment. They are mostly for fleets and for public transportation, not for domestic vehicles. That you can put the investment in an electric vehicles in a plan for a company, an industry, and to show it as a development of efficient project. And so you have a tax reduction in your whole project of the company. Electric vehicle has reduced vehicle patent, they have bona fide insurance, and they can get energy efficiency certificate. That is something that the ministry will pay you some money if you show that you have substituted a diesel vehicle with an electric vehicle. We started in 2013 with the development of policies for the public transportation. In 2019, there was approved a law with specific subsidies for electric buses for public transportation. Essentially, it covers the difference in investment cost between a diesel bus and an electric bus. And it is something that is given for the company that makes the investment. It covers the difference. This instrument is enough to cover up to the 40% of the fleet, to the transformation of 4% of the fleet approximately. But from a fiscal perspective, it's equivalent to an existing subsidy that we have given to diesel. So there is no change in the money that the state has to give for that. And it makes sense to give it to the transformation of the public transport. The electric cabs, since the first units came in line in 2015, the public utility sees the development of electromobility of course, another mean for selling electricity. So at the beginning, they gave money for the people that were buying electric cabs in order to reduce the investment cost. We have developed standards for the connectors. We have developed regulation for the installation of public charging infrastructure. We have developed the electric route. It has been developed by the public utility. It has a fast and semi-fast public charging infrastructure all over the country. The objective, it is almost there, is to have one public charging point every 50 kilometers. And the challenge here is to be able to include private investment in the development of public charging infrastructure. So we are working in develop. I mean, it's not regulation because it is not, but to explain how it can be developed for private investors. So they will have the certainty that we will be able to charge for the electricity sold or for the service provided when the cars are parked in the public places. So the main ideas for the development of electromobility in Uruguay is to have an organized development from the beginning, to take care of the user experience. This is very important. We have a very long discussion. In Uruguay, we discuss a lot. We have a very big discuss of whether we should forbid the import of certain types of connectors to Uruguay. In the end, the idea is, well, the importers can import cars with different standards for the connectors, but the public infrastructure, the public charging infrastructure has always to have one type 2 or one type CCS2 connector available. If you want to install a GBT, if you want to install Japanese standard, it's okay, but you will always have to put there a type 2 or a CCS2, so you know that in Uruguay, the public charging infrastructure is almost developed in type 2 and CCS2 type of connectors. And then the other pillar there is green hydrogen. We have recently published the hydrogen development roadmap, where we see an opportunity in the development of green hydrogen, because of the 98% of our electricity comes from renewables. So we're talking about green hydrogen. And we get a very high capacity factor, at least 60% of capacity factor, with a combination of solar and wind. So that gives us an opportunity to have a low price for the green hydrogen. Of course, this is what we would like. We're working on it, okay? So what are the conditions for hydrogen export? We have a port on the Atlantic Ocean. We don't have major climate events or social conflicts. As I said before, we're slightly undulated plainland. There are no mountain ways, with access routes to the entire territory and infrastructure for domestic transport. We have excellent wind and solar combined resources onshore, and we have the possibility of expansion of offshore wind. So the main ideas for development of hydrogen in Uruguay is start with domestic development, mainly for long distance heavy transport, put our focus on synthetic fuels and green fertilizers. And we're working right now in a few pilot projects, that small scale, to be generated in the country in order to learn more about hydrogen, but we're just starting. One of the problems that we have with hydrogen is our size, is that the project of hydrogens that tend to look at hydrogens for export are very big for our electricity system. So that's a challenge that we have there, that we have to grow. We have to take a huge step again, like we did in the past, to be able to have that possibility. So I think, okay, it's just 3 minutes. Thank you very much for your attention, and I'm open to your questions.
Well, thank you, Virginia. This is a comprehensive presentation and really fascinating, so many different ways, aspects. So I'm hoping that there are questions from the, I'll first of all open the floor for students to ask questions. And again, I remind the students, if you have a question, please unmute yourself, introduce yourself, and ask that question. So again, students, questions for Virginia. Unmute yourself, introduce yourself, and ask the question, please.
Hi, My name is Alexander Gardner. I'm a student with the ESE program. I just want to say thank you for your talk. That was really cool to hear about. I was wondering about the shared assets that Uruguay has with Argentina. And I was just curious, like how that works, if there's ever any like conflicts with that, if maybe one side needs to draw more energy than the other, how does that get worked out and resolved?
Yes, Alexander, thank you for your question. No, the development of that shared hydropower plant with Argentina has been an example of sharing a natural resource in very good terms. Of course, there's a protocol there because sometimes they may need more power, or sometimes Uruguay may need more power. So they have developed a protocol that operates with a virtual level of the storage, and they calculate the usage of water of each country. So they keep like a register of what you have used, what I have used, and to go there with the real level of the lake and the virtual level of the lake, and to see and to share specifically the energy between the two countries. I mean, Salto Grande is always put as an example of sharing a natural resource between two countries. Luckily, we have succeeded in that.
Thank you.
Okay,
welcome.
Questions for Virginia? Please unmute yourself, introduce yourself.
Hi there.
Sorry, go ahead.
Yeah, so my name's Garrett Moyer, also a current ESE student. I also work for a utility here in the States. I was just wondering, as far as reliability concerns, I didn't know if you had any, like with such a high penetration of renewables in your grid, if you have any reliability issues, and if you had any metrics like comparing yourselves to other countries as far as what reliability your grid sees.
I mean, I don't know if I understood correctly. If we had major problems with the operation of the system.
Yeah, like more from like if you ever have issues with not being able to meet demand, and if you have to have rolling blackouts or so things of that nature. Like I was just wondering if you guys have any issues with that.
No, we haven't seen an increase of issues in the electricity supply, different that but we have in the past. Like every electric system has its own indexes. As I said before, it took some years for the national dispatch center to feel more comfortable with wind and solar generation. That was what I shown in one of the slides. The curtailments at the beginning were higher because they tend to not be so secure about confident. I mean, about the operation of the system in certain points, and of course because they developed another ways of better use the energy, because we have congestion or because we have some lines that traditionally have some ratings for the operation, and they discover that they can rise those rates of the lines, in giving the dynamic line rating that they have put in operation in some specific lines. So, but to answer specifically to your question, no, we haven't seen I can't find the word. We haven't seen a decrease in the reliability of the system from that kind of operation. No,
Thank you. Appreciate it.
you're welcome.
Hi, Virginia.
Alberto, you have a
My name is
question?
Alberto. And I'm faculty in the economics department. I'm Colombian, so like we're from the same continent. I
Hi,
have a
Alberto.
question, nice to meet you. So I have a question regarding the operation of your market. Have you seen increased participation from financial, like for example, entities, which actually do not have any kind of assets, but they're just kind of like here in the US, they're called virtual traders. And do they serve? Well, like I guess like there's two questions. One is whether you have this kind of like financial entities that are participating, and whether you see that they play any function in risk management.
I mean, the financial entities were just they didn't take that much risk. What we seen in the early times of the development of renewables is that they wanted to have everything covered. So the least risk that they see, it was just a threat that the project won't come in line. And that was why I was saying that the arrangement of the electric sector in Uruguay, I think it was key for the development of renewables, because as we have the public utility, that it is state-owned and it has a long tradition of fulfilling its contracts, that was just the guarantee that the banks needed to give their loans to the investors, because they are sure that they're going to buy the electricity generated for the next up to 20 years, because not all of them agreed on contracts of 20 years, but they have the possibility. They choose, some of them choose a little bit less, but most of them is 20 years. And I have to give you more on that. When they signed the contract, we have in mind, because I was there in the design, that they will have to buy all the electricity, and we weren't very specific on how to manage the curtailment. That was one big issue, because we thought that the electric utility should buy the curtailment, and we have to, after the contracts were signed, we have to add a new regulation to get very clear that curtailments will be paid. And nowadays, all the generators that have contracts with the public utility are in a system where the National Dispatch Center calculates from the wind speed how much they would have generated if they wouldn't have been curtailed, and that energy is billed to the public utility. We think that this was a risk management, and you will know better than me, a good risk management tool, because we think that if we haven't have done that, then they would have charged us with very much higher prices to cover for that risk, because it is, as I said, the generation is a free market. Everyone can come in line if they want. So you don't know how much curtailment you will be subjected to, and if you don't know, well, you tend to put to cover for that risk, and we don't have it.
Yeah. So it sounds almost kind of like paying the opportunity cost for those generators. But
yeah, you will have, you pay, yeah, you pay everything for them. So I will pay you for your investment and a reasonable return
on investment, yeah.
Investment, yes, and that's it. That's the way we think it's best for the development.
Right. Thank you so much, Virginia.
Thank you.
So Virginia, in the chat box, we have a question from one of the students. With biomass electricity generation, do you have a policy to avoid drastic deforestation? Or your biomass seems to be a large contributor to your renewables.
Yes,
Do you have
but
policies
the
in place?
develop, yes, but because this was just a state policy that has come from before the energy the energy policy, that it was to develop forestation specifically for that purpose. So this is not something, we don't have forest in Uruguay. We don't have that kind of things, but the development of forestation for biomass is specifically developed for that purpose, and those trees have been growing for the last, I can't remember, 30 years. They started with the development of this kind of forestation, and they are developed for that specific reason. So it is not in a non-controlled deforestation.
Okay. Another question in the chat box. This relates to energy storage, Virginia. I heard you mention that you happen to have a pump storage capability for renewables, or?
No, the hydropower plants are not pump storage. They have just dam and lake there. They're not pump storage. We have checked for the potential for pump storage, and we have found that what we have some places that have good potential for pump storage development. And at some point, I may say in 2015, we see in the future that perhaps pumped storage will be a reasonable at a reasonable cost for the development in the electricity. What has happened? It has happened that what we are seeing now in the future is that the distributed storage that we think will come from batteries, it's always taking pumped storage more and more into the future in terms of cost, because the pumped storage potential places that we have were around 300 megawatts, and it's very big compared to the development of batteries, that what we see will develop in a very low scale, but in an accumulated capacity will end up throwing pumped storage in terms of cost more and more into the future. So we have the potential, we have some places that we have identified, but we don't see it as an option, as an economical option to be developed in the near future.
Let's see, questions on the chat box. One question, Virginia, one overriding question. One of the points you made was over 40, 50 years, your GDP has increased threefold, but your percentage of fossil fuel is almost constant. And it seems that you almost eliminated fossil fuels for electricity generation, and now you're making an attempt to go with electromobility to electrify transportation, and all with hydrogen. So that's really quite a step that you guys are taking.
Yes.
And the other point I wanted to bring up, and if you could comment on this, the carbon footprint per capita in Uruguay is one of the smallest for a mid-sized country with GDP like $16,000 US dollars. So there's a lot of human behavior aspects that Uruguay has been able to promote that maybe many other countries have not been able to do that.
Yes, when you put it that way, I mean, perhaps because I'm part of the country, and it seems like a natural thing. I've been through this transformation, and I think that it has covered. It was very. I don't know how to say this. Was very visible for everyone. The development of renewables and the commitment, and we put a strong component in education, in taking that to the children, for them to be able to see that, to see the importance of renewables, and of course it is a kind of something that we have in ourselves, that in Uruguay, it is not easy to have to have things. I mean, things cost a lot. Things are expensive in Uruguay if we compare to other countries. So we tend to take care of our personal investment. We're not a very consuming, I don't know if the word is consuming, I can't find the word right now, eager to consume. We're not eager to consume, to buy a lot of things. We try to get arranged with what we have, and there's something that is not from now. It's from a long time ago. I mean, from our parents and our grandparents.
Rudy,
I find it hard to explain.
Rudy, I have a question or a comment. Rudy?
Yeah, Hal, please go ahead.
Yes, Virginia, I'm absolutely amazed at what your country has done. And to me, it gives me hope for 2050, when we have to supposed to go carbon free. So I think your country is a terrific example of what is possible. And are you sharing this information with the world? Like, for example, do you have a presence at COP27? Are you sharing this wonderful story with others about what can be done and what are the possibilities?
I mean, of course, we are open to talk about it as many times as we can. We have some ministers of the government that are present at the COP that is being held, and also we work a lot with international agents. I mean, Rudy came to know me in an IRENA presentation, because they tend to look much for us to share our experience in different points of view, because I was very fast right now, but there's specific things to be done in generation, in transmission, in efficiency, and we have tried to be as much open as we can, and in the last month we have had much interest from European countries to learn about our experience, but mostly driven by the need to develop hydrogen. So that's what we're sharing right now.
Yeah, a wonderful story, and you have great examples to give to us in the United States. I wish more people could understand possibilities of the future rather than being so down on the future. That this is what's possible, and that's wonderful. Thank you very much.
And
thank you.
just following up on your comment, Hal, that's one reason I was really fascinated with what Uruguay is doing, and Virginia, talking to her and having her present this, gives us a lot of hope in the way forward. As much as we know how to decarbonize, I don't think we've really learned, the world at large has not learned, how do you live with a decarbonized world?
Yes, exactly.
And some of the examples are being set in Uruguay. It may be very difficult to emulate that in the rest of the world, but definitely there's a path forward. Yeah, one thing that I read about Uruguay is, it's not supply always wanting to meet demand. It's sometimes the other way around. Demand needs to meet the existing supply. And so, your statement about when you have excess solar and wind generation, you have a strategy to use that for electromobility. To be able to implement that in most other countries would be very difficult because it would mean altering human behavior. So it's a very interesting strategy that Uruguay has demonstrated that works. It may not work for a very large country like US, but it definitely works there.
Yes, I mean, we're working on the development of electromobility. What we're seeing is that each year it duplicates the number of electric vehicles, and we have quite a challenge there because there are a lot of things that we're always running to develop in order because it compromises the success of the policy. I told you about the development of renewables, and now it's a success story. But when you live day by day in the development of that, at some point it was very difficult.
Yes.
Very little things that happen that you have to cope with and that you haven't taken into account. But it was for me, it is a very fun experience. I think that the energy sector and the electric sector is in one of the best moments to be working in it.
Well, there's time for one last question in the chat box. Virginia, you mentioned that your sources of energy are interconnected rather than integrated. What benefit will integration bring to your operation?
I mean, well, I think, I mean, there's something that is like a common phrase is the larger the system, the most you can develop renewables. The more diverse the system is, the better that you can work with the variability of renewables. And in our country, we are a small country, and it is almost the same reserves all over the country. I mean, if you have a peak in wind in the south, 2 hours it will be in the north. It's just plain there. But if you are integrated with Brazil and with Argentina, that are larger countries and have a diverse regimes of wind and solar, you can have more potential there to cope with those variations. And also, just because you can, if you have energy here, you can offer to them, and you can try to operate in an integrated manner. But that is something that is very, very difficult for us. We are a small country. We have always had the mind in integration. We take part in many commissions and things, but it's difficult because you will see it. But the big countries, sometimes they have other problems, for us, we are very few actors there, and perhaps it's easy for us to align them in a common objective. And when you have a bigger country with different authorities, it's difficult. But I think that the systems integrated it will be better for the development of renewables to get the most from the different wind and solar regimes in the different countries.
Well, thank you, Virginia. This is a fascinating talk, and as some have voiced, there's a lot of things that we could learn going forward. And I really appreciate your patience in making this presentation, listening to the questions and answering them. Obviously, this is not the last time we want to work with you, Virginia, and we look forward to seeing you in other forums. I just want to remind the audience, we'll have the seminar will terminate this fall with a presentation on November 28th, again, 2 weeks from today. Again, thank you for your attendance, audience. Thank you, Virginia. And we look forward to seeing you 2 weeks from now.
Well,
All right,
thank you very much for inviting me. It was a pleasure to be and to talk to you. And I'm at your disposal. If you have any questions, do not hesitate writing to me, and I will do my best to answer or to give information.
Will do. Thank you much.
Thank you.
Thank you,
Bye-bye.
everybody. Bye-bye.
Thank you.
So Susan, let's see. Can you stop recording?
I'm here.
This recording button goes all over the map. Where is it now? I just stop it right there. Oh, there's